Okay, I will do 15 through 20 here. I'm not going to show every single one, but this one, I can just see a lot of students looking at this and being very intimidated. But if you think about it, it already has a common denominator in all three spots. So if we multiplied both sides by that common denominator, since we don't really have much work to do that, if we multiply that side and this side by x squared plus x minus 30, this is really over 1. This would join both tops and it would cancel those out. Okay, same thing here. Oops, minus 30. So if I multiplied that to both sides, to this side, it would end up canceling that out. So, long story short, that bottom completely cancels out because it's the exact same. It's just like the other ones. But we didn't have to do any work to get that. So this is 1 equals. Now it's still a big strand of variables and constants, but if with a little bit of work we can put all this together. So when we simplify this side, we get 8x squared, the 2 and the 6. We get plus 34x, that's the 6 and the 28, and then plus 34, that's the 4 and the 30. Okay, now this is still equal to 1, so to solve a quadratic, I must set it equal to 0. So I have 0 equals 8x squared plus 34x plus 33. Alright, so I know a lot of you are going to be intimidated and possibly not want to try to factor this because 8 times 33 is a pretty big number to look for the factors of that. But 8 times 33 is actually 264. Alright, and if you're looking for factors, 12 times 22 makes 264, and if you think about it, if you add those two, you get 34. Now, the problem with that is a lot of us forget this step, and once you find the factors of 264 that make 34, you have to divide it by 8 and reduce. So when you reduce that, you get 4 goes in there 3 times, and 4 goes into 8. So I reduce that to 3 halves, and then 2 goes in there 11, and 2 goes, so that reduces to 11 fourths. And then that turns into the 2 comes out front, and the 4 comes out front with the x's. So that's how you factor that. So then you could set these equal to 0 and solve. Alright, and I'm going to run out of room, so I'm just going to give you the answers. But you would basically subtract 11 and then divide by 4. So those are your two answers. Now, a lot of you will rely on the quadratic formula for this one. So, which is totally fine. I mean, if that's the way you like to solve, then that's fine. So, just to save time here, hopefully you can see it. It's a little... So if you look at the quadratic formula, just plug in your a, b, and c. You get the square root of 100, which is just 10. So then you got to do negative 34 plus 10 over 16 and negative 34 minus 10 over 16. When you do those two, you get the same answers, negative 3 halves and negative 11 fourths. Okay, I'll show another one that needs the quadratic formula. So number 16. Again, this is a really good problem when you're thinking about, or practicing getting common denominator. They need each other. So this is x plus 4, this is x minus 6. This one needs the x minus 6, and this one needs the x plus 4. Obviously this one needs x minus 6 also because it's the same as that one. So when I go to rewrite this one already has the x minus 6. What does it need? It needs the other one. So that's going to require foiling there. This one's only going to require distributing because this is x plus 4. It needs the other one, x minus 6. And this one needs x minus 6 also. So you notice I have the exact same thing on the bottom. Once I have that, I can cross it out. Foil, distribute, distribute, and we're off. So when we foil that, we get x squared plus 4x and 5x make 9x plus 20 plus 8x minus 48 equals 4 times x, and then 4 times negative 6 is negative 24. This is number 16. So when I put these all together, I get x squared alright, so plus 17x, I'll show this in 2 steps. So plus 17x and then minus 28 equals 4x minus 24. And then we're going to subtract 4x from both sides. We got to set this thing equal to 0 to solve it, and add 24. So when that's all said and done, I get x squared, room here, plus 13x minus 4 equals 0. Okay, so if you think about this, you try to factor this, two things that multiply to negative 4 but add to 13, that's impossible. So you're going to have to resort to the quadratic formula to solve this one. So we're going to do negative 13, negative b plus or minus b squared minus 4a, which is 1, c is negative 4. The negative sign is very critical there, over 2a. If you don't have that negative sign there, you're going to get it wrong. So it's very important. So negative 13 plus or minus, when you simplify the discriminant there, you get 185 over 2. So I've been kind of letting you guys get away with just leaving the answer like that. This is x equals versus writing it out in 2 separate things. So I would take that as an answer. If I did ask for the decimal answer, you'd have to do negative 13 plus the radical 185 over 2 and negative 3 minus 185 over 2 to get the decimal forms. Alright, number 17. This is the last. I believe this is the last one I'll show real quick. Again, they need each other. So this one needs an x plus 5, or x plus 2. This one needs x plus 5. This one needs x plus 5. So we have 10x on top, but I have to multiply an x plus 2 top and bottom. This one needs the x plus 5. So does this one. So exact same thing on the bottom. It's gone. Distribute, distribute, distribute. So not too bad. 10x squared plus 20x plus 2x plus 10 equals x squared plus 5x. So when I put this all together, looks like I have 10x squared plus 22x plus 10. And I would subtract, I gotta get this thing equal to 0. So subtract 1x and subtract 5x. So I looked with 9x squared plus 17x plus 10 equals 0. So again, you could try to FOIL this thing. 9 times 10 is 90. Find factors of 90 that make 17, and you would try for a while and you'd be unsuccessful. So you have to resort to the quadratic formula. So I didn't write it down the last time. It's negative b plus or minus b squared minus 4ac over 2a. So let's use it. So negative 17 plus or minus the square root 17 squared minus 4a in this case is 9 and c is 10 over 2 times 9. when you have to simplify that. When you do that, you get 71. Actually, negative 71 over 18. So you still see that. And when we have a negative radical, that becomes an imaginary number. So this is an imaginary solution. You have negative 17 plus or minus I radical 71 over 18. This is x equals. So your answers end up being imaginary solutions. So quite a bit of work there, you notice, and I'm writing kind of big, but it took up almost a whole sheet of paper to figure that out. Okay, number 18 is another one that has just a rational solution. Notice that this is not imaginary. Number 19 initially comes out as 4 plus or minus 4i, and before that you end up with this statement. It's 4 plus or minus the radical negative 16 over 2. So rad's negative 16 is 4i. Think about it. The square root of 16 is 4. The negative in turn turns into an I. So 4 divided by 2 and 4 divided by 2 end up